have been on the previous webinars, so welcome Lars, Carlos, Sigridur, and Tarik. If you have any questions, please post them in the comment section in the chat, and we can start off with the presentation about the impact of LED lighting on road safety, environment, and budget of municipalities. Most of you or all of you know the rules of our webinars, so I will skip it today. The webinar agenda is, as title says, we will concentrate on road safety, then the environment and municipal, the influence on municipalities and their budget. And today we have again some awards from Osram, because our street lighting family of products, Cordoba and Toledo,
is based on Osram components, so LEDs and drivers. Exactly.
So that's why we decided that we will be sponsored in this webinar by Osram. If you are willing to receive some gadgets, let us know. We will ship them to you afterwards. So starting off with the first topic, LED lighting influence on road safety. We will talk mostly about the crossroads and
pedestrian crossings. Yes,
pedestrian crossings and the influence on the safety on the pedestrian crossings. This is lately quite a big topic for us. Only in our own city, we've done more than, I've heard even 50 pedestrian crossings only in our city. When I'm traveling across our city, I see the lighting supplied by our company a lot. Very proud of it, because the crossroads, the crossings for pedestrians are, the visibility is much improved. So we will talk about the problematic localization of the poles and the luminaires itself.
Yes, so basically the main challenges for that kind of lighting is localization, very often, proper illumination of pedestrians, which is the main goal of pedestrian crosswalk lighting, choosing right CCT, which we will talk about a little bit more,
the light temperature,
and something that is new and more common in Europe, but gaining some popularity in Poland also, active crossings.
All right. So the requirements of the pedestrian crossings. What is the like European standards, and what is required from it?
So we have three steps. We have proper lighting classes. So directive responsible for the information about lighting for the street or road use. Also has a section which tells you what kind of parameters you should fulfill to have a proper amount of light and proper way of light on the pedestrian crossing, to increase the safety of pedestrians in these areas. In general, I'm not going to go into much detail. In general, the directive itself says that light intensity on pedestrian crosswalk should be at least 3 times higher than the average value on the road itself. That's one thing. The second thing is that it should have it should use a different CCT value in order to create a color contrast. So not only brighter illumination, but with a different CCT that will increase the visibility.
So what's the minimum difference? Like if there is a standard sodium luminaires around 3000 Kelvin, so we should place at least 4000 Kelvin, at least 1000 Kelvin of a difference is enough?
It depends on the specifications. So every municipality or every governing body which is responsible for road lighting in every country has its own guidelines. And oftentimes they specify it per city or per municipality what should be the requirements. So there are municipalities which require pedestrian crossings with 6,000 Kelvin, or and general lighting on the road 4,000 Kelvin. So some municipalities in Czech Republic right now decided that 2,700 Kelvin, this is the standard color temperature for the general road lighting. So you could, for example, use 4,000 Kelvin on the pedestrian crosswalk.
And for example, Polish authorities for general roads, highways, and expressways, they require at least 1,000 Kelvin difference. So if around there is 3,000 Kelvin, it is required to put 4,000 Kelvin. If it's 4,000 or 5,000 Kelvin, then you can use a warmer one. So it doesn't matter if it's warmer or colder. Light temperature, it's important that there is this differentiation, at least of 1,000 Kelvin. 2,000 Kelvin is even better because the contrast is even stronger.
Yes, especially if you have a contrast from general lighting that is neutral or warm, and you do the cool temperature on the pedestrian walk. This contrast is very stark, especially at night, because when the drivers are moving around, let's say not in the city, but on a dark road where you also have sometimes pedestrian crossings, their eyes are more sensitive to cooler light because of the transition into a mesopic region of the retina. It's a completely different thing, but it's based on what we talked before about the influence of lighting on employees, on people.
So we will cover that later in the presentation, but like generally what we recommend is using warm temperature on the streets, on the roads, and for crossings, colder one.
Yes.
We will explain why later. Right now, what is important is that you get the contrast. And from warmer to colder, the contrast, the perceived contrast is better.
Yes, and this is the example of pedestrian crosswalk lighting, which is done in a two-way road with single line in each direction. So as you can see, we have two lighting poles. This is directed for the right hand. So when you drive on the right side on the road, if you would have example with the left side of the road driving direction, you would simply change the direction of the luminary. So this luminary would be mounted here. This luminary with the pole would be mounted here.
So it will be opposite, right?
Yes, exactly. And why it's done like that? The most important thing about the illumination of the pedestrian crosswalks is not only to provide higher illumination value, because it's not the case of the horizontal light intensity. Because
with the pedestrian crossing, we don't measure the surface or like 80 centimeters from the surface horizontally, like it is usually for offices, warehouses, and so on. What we have to measure is the luminance vertical. So adjusted to the height of the person throughout entire crossing, plus at least 1 or 2 meters beyond the road.
Yes, exactly. So the so-called waiting area, where a pedestrian waits to walk through the crossing, and then that's the most important thing. Oftentimes you can find projects where it's set to use at least 100 or 150 watt LED luminary on the pedestrian crosswalk, but from the perspective of proper design, you only need lamp luminary that has between 6,000 to 8,000 lumens of the output. So depending on the model, this can be from 40 to 60, 70 watts of power, actually maximum. And the most important thing is to have the right illumination at the side of the person, facing the direction of movement. So when the driver goes and the pedestrian walks into the crossing, this side that is seen by the driver is very well lit and provides very good contrast with the dark background, hence different CCT value to provide contrast with the background lighting from the road itself.
And what we said, it's also this waiting area has to be really well lit, because we don't want this effect that finally the pedestrian appears on the crossroad.
Pedestrian suddenly appears on the road,
on the crossing. Yeah. We want to see him before he enters the road, the crossroad, and it improves safety by really a lot. So that's important. And this is really good visualization of what we want to achieve.
Yeah, this is the false color image of a similar to the previously shown pedestrian crosswalk on a two-line road. You can see here the colors from the black to white. Black is the lowest illumination, white is the highest achievable illumination. So in this case, with this particular setup, we have very good illumination of the person on the crosswalk. What is also important is to adjust the height of the lighting pole. Typically, it's between 4 to 6 meters. But if you use a lower one, you can then have a better illumination on the bigger portion of the silhouette of the person from the side, which will also improve visibility of the person, especially if they are wearing dark clothing in the winter, for example. The next one is basically shown how the value changes as the pedestrian is crossing on the other side. So in this case, it is illuminated the same as it was very uniformly illuminated from this side. Then on this side, driver from the other lane also sees the person properly illuminated. Yes, and another modification for pedestrian crosswalks are active pedestrian crosswalks. So what do we mean by active one? Basically, you have a illuminated D6 sign. This is the information sign that says that this is a pedestrian crosswalk. It has a constant illumination on its own, so it's very well visible from large distances. Lighting poles have built-in motion sensor, a speaker which provides a audio feedback for the pedestrians and for everything around them, and of course additional warning lighting in the orange or amber color built into the pole. And how it works, we will basically try to show it to you. We have made a sound project with our partner.
Gmina Jawór stawia na bezpieczeństwo oraz nowe technologie. Zwyczajne przejście dla pieszych, a jednak niezwykłe, dobrze oświetlone, wyposażone w sygnalizację świetlną, a do tego jeszcze... Gmina Jawór stawia na bezpieczeństwo oraz nowe technologie. Zwyczajne przejście dla pieszych, a jednak niezwykłe, dobrze oświetlone,
there is a big contrast between
w sygnalizację świetlną, a do tego jeszcze mówi.
Versus the rest.
Takie cacko uruchomiono na ulicy Wyszyńskiego. Gratulujemy pomysłu, bo bezpieczeństwo jest najważniejsze.
and this provides a good contrast for the driver. So when there is nobody, warning lights are turning itself off, and the sensors are waiting for another people to approach and activate the system.
And we are supplying also this kind of systems with the company 𝐼𝐥𝐺. 𝐼𝐥𝐺 is producing the composite poles, and they are using our luminaires for that. So we can supply you the full package for this kind of an active pedestrian crossing.
And this is very popular in the Netherlands lately, to use this kind of lighting on the pedestrian crosswalks, because it improves visibility, and it improves safety, especially with the warning lights in the orange activated by the motion sensor, and proper illumination of the crosswalk itself. Okay, and we are still talking about the CCT, proper difference in the warm to cold. Why is that? We have a few reasons for that. So let's start with one thing, is that we try to convince our customers that they should use warm CCT as a general street lighting. We will talk about this in the next section about the LED lighting and the environment. And then we want to increase this contrast. So as I said before, because the human eye adapts to the surrounding conditions, during the night, our eyes are slightly more sensitive towards cooler light. So if you have a general light that is warm and provides good illumination, you only need this 1000 Kelvin difference in CCT. But if, for example, you have a dark road with no lighting and there is only an active pedestrian crossing with no other lighting around on the road, which is lit, then creating this colder light in this area gives a better perception for the driver, because his eyes are more sensitized to cool light, because it transitions from the photopic to scotopic vision in the eye. This is called a mesopic vision, because the scotopic is only in total darkness, so not in this case. There is always some kind of light, but this is this transition region which causes the eye to be slightly more sensitive towards cooler lights, cooler CCT. And in case of the warm CCT for the general lighting, this we will be talking about the environmental.
So what I want also only to say when we are watching this graph and this diagram is that we always want to understand what's the spectrum of the LED lighting, of the artificial lighting. The natural light has pretty a lot of blue spectrum of the light. The LED lighting also has pretty dense or intense part of the blue light, but as we can see on the picture here, around 400 nanometers of the wavelength, but it drops down towards colder CCT. But anyways, this influence of the blue light on the environment is very important, and this is the second topic we will cover today.
Yes.
So to summarize the conclusions and the recommendations towards the pedestrian crossings.
So first one, use contrasting CCT. So that's the first thing. So the requirement is that you have to create the increased contrast between the general road lighting and the pedestrian crosswalk lighting. Second one is local authority guidelines. Yeah. You have to obey this because every municipality, every city, every state can have different requirements. So when you do the audit for that, You have to gather every data about the installations, luminaries, and requirements that need to be met by the customer. And then from that, you can apply whatever you need to achieve the high contrast, proper illumination levels, proper illumination angle, so to choose the right optics, right pole height, pole placement. The third one is suitable lighting pedestrian profiles. So basically, that's the beam angle, so the type of the optic that you use. It must be optimized for that specific reason to get the best possible side illumination for the pedestrians.
And the power reduction, be very aware not to usually use the power reduction. Concentrate on the vertical illumination of the pedestrians. The power is not that big issue. You don't use a lot of power, as we told you.
On the pedestrian.
You will use from 40 to 70 watts maximum, and you need only 2, maximum 4 luminaires per crossing. So that's not a lot of power. You will save more on the general road. And on pedestrian crossings, be aware that getting down with this 60-80 watts per crossing is not that a lot, and we want to achieve the safest crossing as we can, because a lot of actually accidents happen on the crossroads, on the crossings,
which are badly illuminated or not illuminated.
In the entire world and in Europe, most traffic accidents are happening with the pedestrians, and that's why it's extremely important to concentrate on the safety part of it.
Yeah, and power reduction, again, you should consult the guidelines from the local authorities, and then you can use power reduction only in places where there is very small traffic, slow moving traffic, and only in some parts of the night where there is low amount. So depending on the situation, we do not recommend. You can do this, but do it carefully, only in the places where you have very low amount of traffic and people. The fifth one is additional marking. So active signs such as active crossroads, D6 sign that is illuminated all the time, or motion sensor activated warning lighting that will flash orange towards the drivers to inform them that, okay, they are far away, they don't see the pedestrian, but they see flashing lights, so they have to slow down because somebody is crossing the crossroad at this time.
And we are supplying the full package with Alumast, Polish composite poles manufacturer, so you can ask us for those active crossings as well. And the sixth conclusion is luminaires on both sides of the road, opposite sides. Yes. So you get again very well lit the vertically the pedestrian.
That's the proper illumination. We talk about this because there is oftentimes there are some old pedestrian crosswalks where there was one luminary mounted in the central point above the pedestrian crossing between the lanes, shining down only one way. This is the bad way to do this. It was done in times where the only requirement was that to have the contrast and higher illumination level, but nobody thought about the side illumination, the contrast against the background. So
what you really want to achieve is that the upcoming car sees from his side, sees the pedestrian.
Yes,
and
well illuminated.
This is the horizontal lighting that you need to achieve vertical lighting that you need to achieve to increase safety. And the second topic is the LED lighting influence on an environment, and this is a topic that really interests me a lot, and it covers the light pollution, we said in Europe, but in generally that the light pollution is a problem to the whole world. The same is for Tariq and the UAE. So actually the Emirates have a really big problem with the light pollution since they are using a lot of lighting on the buildings, a lot of decorative lighting on the buildings that are flashing all the time. And this is not only a problem to environment like birds and other wildlife, but also to the people. The light pollution, you see the effect, Patrick can say it because he's a photographer. You can see the effect at the night when you want to go out and see the sky and you want to see the stars, right?
Well, basically, as we will talk here about, this is just a picture from International Space Station flying above the Europe. This region here, this is Netherlands. So you see, this is the London and the south of the UK seen from here. This here is France, so you can see the Paris region in here. Some other bigger city, I don't know from this picture what it is. So all of that is light coming from street lighting, building lighting, effect lighting, some decorative lighting. And the color is mostly from the sodium type of light sources. And the problem is quite big because as of 2001, in a study, it was shown that 18% of the surface of the world is affected with the extreme light pollution, or light pollution in general. This is connected with every highly urbanized area where there is a lot of people. There are big cities, high density of people per square kilometer.
And if you look at the UK, you get like 85% of light polluted areas. Netherlands, 100%.
Yes, there is no place in Netherlands where there is no light pollution. And somebody might say, well, but why is it a problem? Well, it's a problem in a couple of reasons. This here is the map from last year. This is the light pollution data in the Europe, most part of the Europe actually, from the last year. So basically, as you can see, Netherlands region, it's orange, reds in this area. So every time you see a dark red color, this is the most affected region. This is the Moscow. This is the Paris. This is the
of course
Warsaw.
You can see it. With a big light, the lighting pollution covers mostly the agglomerations, big city complex. The more people there are, the more street lighting there is, and the bigger lighting pollution.
Yes.
And how does it affect the environment? So first of all, it does affect the wildlife a lot. I mean, if you increase the light pollution by 50%, so you just put up more lighting around the roads, you will change actually the ecosystem. So there will be increased number of bugs and
well, basically the life cycle of many animals will change, especially birds. But not only this, also can affect the growth and development of plants, mostly trees, as some recent studies have shown that large amount of lights, as this is highly connected with the horticultural lighting, where you use LED lighting or any kind of lighting. Like for example, you use sodium lamps in the growing facilities to improve the growth during the winter time. So if you use the same type of light, the sodium lamp as a street light, and this light is not controlled in a proper way because it's with almost all old luminaries, it's directed almost everywhere, including upwards. Then every plant receives some dose of light which can alter its growth, its health, It can lead to higher amount of diseases like fungus or other bacterial infections, which can destroy the city wildlife and the flora in the cities.
So basically, if you lit up throughout entire night a tree, it will start growing faster in the earlier period, but within the later period, it will stop growing because it used too much energy at the beginning. So it would be like you fuel the trees too much at early stage of its growth, and then it's exhausted and it cannot grow further.
And it can become sick, and then you have to cut it down, etc.
So you want to use as little light except the road itself. So you want to cut off the viewing angles and the light besides the road that you want to lit up. And if you go, for example, to Oslo, or you go to Norwegian cities, you will find out that they use very little of the artificial light at night. They really decrease the light to maximum. And this is a good way. You don't want this kind of a Dubai way where you have, or Chinese, or Las Vegas, where everything is lit up, because it's really bad for the wildlife. The birds actually will see a lot of light as a threat, so they will have to change their path of traveling, and they will have to go around the city, losing a lot of time and energy on their way to on their seasonal movement. So the same actually applies to people. What you want to avoid is a strong light, the street lighting or outdoor lighting at night that lights up your room
directly. Yes.
Directly. And there has been this study based on 100,000 nurses in US, where they measured how much the street lighting, the strong street lighting,
improper street lighting,
improper and strong illumination from street lighting affects their lives. And it proves that if the street lighting goes into your house, to your apartment, and there's a lot of illumination either from reflection or direct light into your windows, the nurses had increased health problems, increased problems with sleeping, and finally it's improved the chances of even catching the cancer. So this is really serious. We want to eliminate the outdoor lighting as much as we can. And I understand in the cities like Shanghai or Dubai, this is very difficult to do because they want to attract tourists. But in the cities, especially in Europe, like Oslo and Krakow or Dresden, and people start to understand that the illumination of architecture of the tourist attractions is not as important as the lives of people and the wildlife. So they decide really to decrease the amount of illumination during the night, or even switch it off after 12 to 5 a.m. So from 12 a.m., from midnight to 5 a.m., there is not a lot of tourist traffic, and you can just switch it off and not lit it up during the core.
Or decrease the light intensity with control systems down to 30%, for example. So it all connects with proper lighting, so proper luminary design, where you have a flat glass, recessed lenses, no 0% ULOR, so upper light output ratio, 100% only in the DLOR section, so the downward light output ratio from the luminary, proper type of lens, so you light up only what you need, not more, and optimized efficiency. So highest efficiency to decrease the power consumption, but lowest power possible to fulfill the requirements of the directives that say that you have this lighting class on the road, you have to fulfill it. That's the reason.
Let's jump into conclusions and recommendations for fighting the light pollution. First of all, the warm CCT. If you use 3000 Kelvin for the general street lighting, I will read it as it is stated. You will influence the decrease of blue light by 27.5% compared to the neutral lighting, so 4000 Kelvin. And if you talk to municipalities, they usually say, okay, we have the sodium luminaires and we want the new LED lighting. So we want to let people know we have changed to a new LED lighting. Let's make it modern, so let's make it very cold, because there is big contrast. So all the inhabitants of my municipality will see the difference right away. Not a good approach. If you change from sodium, let's change to really warm LED. You will see the difference anyways. It's a huge difference.
4000 Kelvin is basically the maximum that we would recommend.
Yes.
General lighting.
Don't go
3000.
3000 is the best. 4000 is acceptable. 5000 or 6000 is really not acceptable for us.
Only for pedestrian crossing for increased contrast. Yes.
Yes. So in general, for the municipalities and general lighting of roads, go for 3000, maximum 4000 Kelvin. On the crossroads, on the crossings, pedestrian crossings, you can use 4000 to 5000. But this warmer CCT decreases the amount of blue light in the lights emitted by the diodes, and the blue light reflects the reflection rate from the road is much higher with the colder temperatures of light.
Actually, that's the reason is a little bit different for that one. So the less the blue light content, you have to things like think opposite of what we talked about the webinar when we talked about the influence of lighting on the workers. So you want blue light content to increase the awareness, increase the alertness and productivity for a short period of time. But on the other hand, you don't want this effect to be permanent when people are sleeping or trying to sleep during the night. So this is the exact opposite. You have to decrease the amount of blue light in order to allow people to rest, because the more the blue light, the worse is the process of going to sleep, because of the melatonin suppression done with the blue light, which is the neurotransmitter that gives you this ability to fall into a recovery mode, a sleep mode, where your body is resting. So warm CCT, minimum amount of blue light content, and the visual aspect, which is very close to the original sodium lamp, which was also much warmer. It was like 1800 Kelvin to 2200 Kelvin, but 2700 Kelvin or 3000 Kelvin, this light is much better because it provides a good illumination. It has very good definition of colors, so you see better. And the second reason is that what Maciej said. So blue light has a tendency to be more diffused, not only on the surfaces. This is the lesser effect, but mostly in the air, especially if you have a high content of moisture, so high humidity, or a slight fog, or dusting in the air. Blue light has a tendency to spread out more. It's more diffused, so it creates something that is called a lighting fog that will limit the distance that you can see clearly during the night.
So if you have the fog, or you have high humidity areas, or your geographic position is that you have throughout the year a lot of moisture in the air, then the warmer CCT also helps you with the visibility. But what I was saying is that the warmer CCT you use, the least amount of blue light there is, and then the least light pollution you have. Because of the reflection from the asphalts, and it's also proved by some research. So this is concerning only the light temperature. As you can see, using the right light temperature outdoors makes a lot of sense. Optimized power, this is opposite to crossroads, to pedestrian crossings. You want to optimize power as much as you can, and thanks to LED lighting, you can do it at least 50 up to 70% only on the light source. You can optimize and further with the control systems.
But again, it depends on the requirements of the authorities and your adaptability. So how much can you change the lighting class on the road? The second one is the light cutoff. This is probably the most important parameter in the light pollution elimination. So what I said, the ULOR and DLOR value. So no light upwards, so above 180 degrees parallel to the horizon, and preferably light only, as in fifth point, optimized lighting project. So the light only where you need it. This is the best way to ensure that you will waste as little light as possible, and you will introduce as little as possible light upwards into the environment.
And the LED lighting is much more efficient here than the traditional ones.
Yes, because of the...
It's so much easier to design, good optics, so you can really direct the light where you need it. And even if you compare only the light sources, you will get like 50–40% savings on the light source, but additional savings come from the lighting design, the lighting optics, and this gives a big advantage. Then using the high quality luminaires, so it's important to use good light source, good drivers,
good
lenses, because you get then really the good quality of the light. Using lower quality of luminaires and light sources really can deteriorate in time, and you will get not the right effects, and you will lose both the safety and the environmental effects.
Or you can have problems with cool CCTs from cheap luminaries,
or the CCT changes in time while the LED deteriorates in quality on time. So it is better to use really good sources of luminaires.
And last one, the light management systems and power reductions. So again, use as much light as you need, when you need, and where you need. So that's basically the idea behind this. If you have high traffic hours, use 100% of your light, but use it considering previous points. So everything that we said above. But then, if you have a night period with very low traffic, you can then either dim the lights down to 30%, 10% sometimes even, or simply turn them off and manage them throughout the whole city. And this will give you the ability to maximize the system. If you connect this with, for example, motion sensors, which are gaining some popularity, you could even do it slightly better. So where there is a pedestrian or a car going, the luminaries before him and slightly after him can be turned on and illuminate his approach through the city, through the road.
We will talk about it in next topic as well, but what is important again is the local authorities have different regulations. And for example, in Poland, the law is not very clear on that, but mostly municipalities and local authorities don't let you dim the lights during low traffic hours.
Yes.
And for example, in Scandinavia, you can almost switch off the lights through midnight to 5 a.m. when the traffic is almost non-existent. If you don't need that, don't use it at all. That's the best cost reduction. That's the best influence on the environment.
Yes. Zero light pollution, zero
exactly.
energy consumption.
If you have a huge crossroads on the highway and there's a traffic non-stop, you want to have the maximum safety, and then you will keep the lights on entire night. But if you don't need to do it, don't do it. Then we have also one question: have you considered 2700 Kelvin in residential areas? We do it only based on special request. So it's a non-standard solution, but we can supply you this kind
yes.
of street lighting luminaires. Is not the problem. So, but it's a non-standard, so you would have to wait.
We would prefer to. We are recommending 3000 Kelvin because if you go down from 4000 Kelvin to 3000 Kelvin, you have the efficiency penalty already. But if you go even from 3000 Kelvin to 2700 Kelvin, this is even bigger loss.
So you gain only 300 Kelvin, but you lose a lot of inefficiency, so lumen per watt. So that's why we considered 3000 the best solution. It's available, it's a standard one, you don't pay more for it, you get this all positive effects on environment, but yet at the same time you don't lose so much on efficiencies. And let's jump to the last topic during the webinar. So this is LED lighting influence on municipalities.
And their budget.
And their budget. So is it cost effective and how much cost effective it is? And I will play a movie first. So this is a medium-sized municipality in Poland, and we used a pretty complex system. We had to rebuild, so it was a modernization. We had to rebuild the existing system and replace it with our luminaires and wireless connectivity. So you can see here on the picture, and actually this lighting in Legnica is connected to the traffic lights and to the traffic so management system, so it recognizes how heavy the traffic is, and it can dim the lights throughout the day, throughout the night, considering the how heavy traffic it is, and is it late night or is it rush hours. And we have done it with our local partner for control systems, and that was one of the more complex realizations. And you can see here that you have the panel for controlling the luminaires, you can see the alerts, you can change the scenes, you can take care of the system wirelessly, remotely, and adjust it to the new needs of the city.
Które nie wiążą zamawiającego tylko z jednym dostawcą.
Okay.
So coming back to the challenges. So the first challenge is doing a good audit, a good checking what really there is on the roads. So if you have good data and a design from the municipality, that's great, but usually they don't have it. So the system was put out 20, 30, 40 years ago, and the data that you have on the design is outdated. And so you have to go to the site, you have to mark the actual position of the light poles. This is extremely important. Usually the light poles were moved, so the municipality doesn't actually know that what they have on the design is outdated and the new positions of the poles have been moved away. You cannot do the design if you don't know the exact position of currently put the poles.
So the proper inventarization during the audit. So you have to count number of lamps, type of lamps that are present, every pole, its exact placement. So if the road will be rebuilt, you can then move the poles, or if there are any obstacles that don't allow you to move it, so you have to use a pole-mounted arm that will extend the luminary in a correct place. So then you have to consider the scope of modernization. So after the inventarization, after the data from the municipality, with your help, should consider what will be the scope, how many stages it will be to modernize the full municipality.
Does it include the cables? Does it include the electric cabinets? Does it include the poles? Does it include not only replacing the poles but moving them? So it really depends. Is it the modernization or modernization with actually building a new infrastructure, electrical infrastructure for new existing design of lighting? And this is pretty tricky in Poland and in Europe as well, because especially in Central Europe, because the luminaires or the poles don't mostly belong to municipality. For example, in Poland, the poles belong both to municipalities and energy providers. So sometimes on the one section of road, you have to talk to two authorities, to the owner of pole, to the owner of the luminaire, and to the municipality. And there could be 2 or 3 actually owners in a one section of the road that you do the modernization with. So it's very tricky. You have to understand the situation before you jump into modernization of that.
Okay, another one is choosing the right light management system for the customer. Now, this is important not only because there is a lots of different systems that can be used. They can be wired, like PLC, wireless. It all depends on the application and what are the customer's needs. This is the most important one.
And so the 2 pretty popular systems are supplied, one by Schroeder, the second by Philips, our competition on the market. And what is also important to understand and to talk to the decision makers is that they should go for the system that is open. Why? Because then they can fill in other sections and other parts of modernization of their street lighting with new suppliers. If the system is closed, then choosing one supplier for one section of the road, then they have to go along with this one supplier to the rest until they finish entire city. And this closes municipality from competition, so the municipality finally gets not that good price and not that good solution, because they have to follow what they have started at the beginning.
Plus, the openness of the systems gives you one more advantage. You can customize the system for your needs. So you select only those features that you use and you pay only for them, not for the whole package. And these costs are adding up quite quickly, because this is the monthly or yearly fee per luminary, per function, per system. So it can be a huge difference in the cost if you have a customized system that uses only functions that are needed by the customer, or that you have a closed system provided by some manufacturer that has all of the features all the time.
And it's also important to be sure that your system that you install is easy for installation, because actually the biggest problems you will have not in designing the system but on installation. So installation and commissioning is extremely important. We always tell our partners to look at the costs of data transmission within the entire contract. So not only within, let's say, 5 years warranty in contract for giving the services, but also beyond that. So the municipality has a low cost of using the system in the long run. So if you look for Legnica, this is exactly this medium size of a city, let's say up to 100,000 inhabitants. We helped the municipality save up to 70% thanks to reduction of power on the luminaires and the reduction from the control system, dimming it, adjusting it to the rush hours and the traffic, and so the municipality can see up to 70% of savings. So this is really a lot. What we see a lot is that somebody designs street lighting, and then the contractor wants to use exactly what was designed, and some of the designs come from 2016 or 2017, so it takes a lot of time from the designing new lighting for new roads, for new highways, for example, and when we come to implementation, a lot has changed. So it's good to write the specification and work with the municipality so they can have an open system and they are open for updates and for replacements. Because we don't want in the specification of the tender to have written they have to use the luminaire of 70 watts and let's say 7,000 lumens, because it gives you only 100 lumens per watt. It doesn't make any sense. It's much better to write we need to achieve above 100 lumen per watt efficiency, and that makes sense for everybody because the municipality can buy and the contractor then can buy 140, 150 lumens per watt. That's much better for energy saving, and the municipality is safe with the specification because they know they get at least 100 lumens per watt. Why did we use, all right, so the 𝐾𝐮𝐫 actually doesn't work in Poland. It's not popular. I know that in Lithuania, Latvia, Estonia, and northern countries, 𝐾𝐮𝐫 is more popular. You have to understand that each country has a different requirements. So there are 4 to 5 standards. There is LoRaWAN, there is LoRaWAN, there is 𝐾𝐮𝐫, there is 𝐾𝐶AMBI Bluetooth mesh, there is DALI, and there is PLC. And each of the authorities, each of the city actually prefers different standards over another. And so we have to understand there is differences in that, and we will help you to supply the correct system for the municipality, but an open one, high efficiency one, easy to install and easy for commissioning. This is our approach, and this is what we want to achieve. And in case of 𝐾𝐮𝐫 connectors, the new luminaries that we are developing right now, so the new series of streetlights will have a 𝐾𝐮𝐫 book 18 connector as a standard. So we will be able to supply you both the DALI, the Bluetooth, PLC, or 𝐾𝐮𝐫 standard. We can help you with all those standards and prepare the solution, either the luminary itself that is compatible or entire system. So wrapping it up, for achieving maximum savings for the municipality, you have to do really good audit. You have to be on site. It's impossible to do good audit without inspecting the site before. Do the right lighting design based on an audit. Use highest efficiency luminaires. Using control systems that is compatible with a local system and is meeting all the requirements from the local authorities. So look only on the functionality, not on the name or
or the brand or the features. The most important thing is this proposed system can fulfill required functionality. If yes, this is the right way to go, basically.
The one of the most important factors is choosing the right electrical contractor. That's really the key. If you have a good lighting design based on an audit, then having the right contractor is a key for savings. And then cooperation with the contractor and the authority, so you can really adjust small adjustments, movements of the poles of the lights, so you really get the maximum safety, efficiency, and the quality, so the end user is happy. So this is it. In 2 weeks we will have a final webinar, the last one for vacations, because throughout June and July and August we will not do webinars. So within 2 weeks we will have a last one. We will talk about CSR, we will talk about CO2 emissions and the influence of LED lighting on that. So more about environment and the influence of LED lighting. And please subscribe to our YouTube channel and our LinkedIn, and see you in 2 weeks. Thank you very much, and talk to you within 2 weeks. If you have any questions on the go, please drop us an email. Thank you.